Hello guys, welcome back to my YouTube channel. So today we are going to solve day 12 problem on Leetcode. If you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. So this is an easy problem, okay? And in this problem we have given an array nums of size n and we have to return the majority element. The majority element is the element that appears more than n by 2 times, and you may assume that the majority element always exists in the array. Okay, so majority element always there in the array. Okay, and in this example 1, this is the input given to us. So this is nums array in which 3 appears the most of the times. So 3 appears more than n by 2 times. So output is 3. Okay, same way for this example, output is 2. So before solving this problem, let's understand one algorithm. So this algorithm is Moore's voting algorithm. So this algorithm is very efficient algorithm for finding the majority element in an array, given that the majority element always exists in the array. So how this algorithm works? So in this algorithm we are going to initialize a variable candidate to store the potential majority element and another variable count to keep track of its count. Okay, so let's say that this is an example given to us. So we are going to start with the element which is stored here. Okay, and we are initially going to start with count as 1. Okay, so in this algorithm, okay, we are going to iterate through the array starting from the second element, and if it matches the current candidate, then we are going to increment the count, and if it doesn't match the candidate, then we have to decrement the count. If the count becomes 0, we have to update the candidate to the current element and set the count to 1. Okay, and after iterating through entire array, the candidate will hold the potential majority element. Okay, and this is the final step. Finally, we have to verify if the candidate is the majority element by counting its occurrences in the array. If it appears more than n by 2 times, then it is indeed the majority element. Otherwise, there is no majority element. But as in the question it is given that you may assume that the majority element always exists in the array. So we can skip this step since it is already given that element always exists. Okay, so here we are just going to give the candidate. So now let's understand this with an example. So let me copy it here. Okay, so this is input given to us. So first what I'm going to do, I'm going to start with this as a candidate, this 2 as a candidate. Okay, I'm going to start with this 2 as a candidate, and initially I'm going to give count as 1. Okay, so let me write these two things here in our code. Step by step I am going to explain. Okay, so int candidate is equal to nums of 0, right, and int count is 1. Int count is equal to 1. So this is the first 2 steps. After that we have to find the majority element. Okay, so we have to find the majority element in our nums array. So I am explaining the code with this example. So in this we have to find the majority element. So I have to run one loop, and this loop is going to start from int I is equal to 0 and I less than n and I plus plus. So this is my for loop, and inside that loop I have to check if the next number. So no, here one more thing. Here we have to start with the first element. So because we have already fixed that our candidate is going to be our first element and count is 1. So let's start with the second element now. So this is fixed. Now we are going to start with our second element. Okay, here see, we have initialized a variable candidate to store the potential majority element and another variable to keep the count track of it. So we have started with the candidate key being the first element in the array, that is this 2, and count being 1. So this is done. This step is done. Okay, now after that we have to iterate through the array starting from the second element. So here I am starting from this second element, I is equal to 1, right, and for each element if it matches the current candidate, then we have to increment the count. So now let's do this step. If it matches the current candidate, then we have to increment the count. Okay, so here inside this for loop I'm going to write if nums of I, okay, is equal to candidate, then in that case we have to increment the count. Okay, so now this step is done. So I'm done with this step. After that we have to check if it doesn't match the candidate, then decrement the count. So if it doesn't match the candidate, let's write it in else. So we have decremented the count. So this is also done as per Moore's algorithm. Okay, so this step is also done. Now if the count becomes 0 at any time, we have to update the candidate to the current element and set the count to 1. Okay, so if it is saying that if at any time my count becomes 0, so can I write it like this? If count is 0, okay, in that time, at that time we have to update the candidate with the current element. So can I write like this? Candidate is equal to nums of I, and I have to also set the count as 1. Okay, so this step is also done. If the count becomes 0, update the candidate to the current element and set the count. After iterating through the entire array, the candidate will hold the potential majority element. Okay, so it is saying that in the end the candidate is only the potential majority element. So let's do one thing here in the end. Okay, so this is a count statement and this is for loop ending here. Now here let's me return what? Return candidate. Okay, so here I am returning the candidate. Now let me run this code. Okay, so here we have to define, okay, int, can I write it like this, nums.length, because, or can I do one thing here, int n is equal to nums.length. Okay, now let me run it. So all the test cases has been accepted. Now let me submit the code. So our solution is accepted and it beats 99.82% of users with Java. Okay, so here see what's happening. So this is the example first. Okay, this is the example. So here, okay, so here what's going to happen? Okay, let's see, understand here it here. Okay, so this is the key. So first I stored this as my candidate. So this is the candidate, first candidate, and I set candidate CA, and I set the count as 1. Okay, then after that I found that this element is the same as my candidate. Then my count is going to be incremented to 2. Okay, count is incremented to 2. After that I have reached here and I see that this element is not my candidate. If this element is not the candidate, then I have to decrement the count. The count becomes 1. After that I reached here and I see this element is also not equal to my candidate. Candidate is right now this CA, na? This candidate is CA only. Okay, so this is also not equal to my candidate. So what I have to do, I have to decrement the count as 0. Okay, so I have decremented the count as 0. Okay, so here as you can see I have decremented the count, so count becomes 0. Now also I am seeing that if my count becomes 0 at any point of time, then I have to update the candidate to nums I. So now my new candidate becomes this CA. This CA is the new candidate and I have to set the count as 1. Count as 1. Okay, now same way I move to next one. Okay, so I find the same element as my candidate, so I have to increment the count as 1. I have to increment the count, so count becomes 2. Okay, now after that I reached here, I reached to this 2. So for this 2, when I reached, I see this is not equal to my candidate, so I have to decrement the count as 1. So at this time here again it is not equal to my candidate. So if this is not equal to candidate, then my count is going to decrement to 0. And now if my count decrement to 0, then I have to update the candidate as this. Now my new CA becomes this element 2. Okay, and count becomes 1. So potentially this is the last candidate that I get. Okay, and this is what I have to return. Okay, so I hope that you guys are able to understand today's problem, and this is important algorithm. That is why I have explained it here, Moore's voting algorithm. Sometimes in the interview they may ask this question, what is this Moore's voting algorithm? So this is the Moore's voting algorithm, and here how it is working, how it works. Okay, so I hope that you guys are clear with this video, and please like, share and subscribe my YouTube channel. Till then, keep coding and keep practicing. Thank you. Bye bye. Meet you in the next video.